This is Makerere University Business School. We are students pursuing a bachelor's degree in business statistics. We are Group 2, evening class, and this is production statistics. Would like to take this opportunity to appreciate and recognize Professor Gideon Kurunziza. We really appreciate you as Group 2 evening class. Today we are going to be going through decision analysis, forecasting, and scheduling. My names are Hwanguen Melissa Abigail, and by the end of this video, we shall be able to understand more what decision analysis is, the challenges, advantages that are faced by production firms. We shall be able to understand more what scheduling is, the different models that are used, and so we shall be able to understand more about forecasting as well. Maybe other members will take an opportunity to introduce themselves as well.
Thank you. I'm Mirembe Phyllis Seruwaji.
Thank you, Melissa. I'm Satongo Steven.
Thank you, Melissa. I'm Mayanja Ali Ahmed.
Thank you so much. I'm Joel Suna.
Thank you, Melissa. I am Nachitende Rachel.
Okay, so Rachel will be taking us through the first part of decision analysis. Over to you, Rachel.
Thank you, Melissa, for this opportunity. I'm going to go through decision analysis. This is the process where one selects one option from very many available alternatives. It has three approaches: a structured approach, uncertainty, mathematical foundation. Under structured, we look at decision trees. Decision trees help us to compare scenarios side by side and we come up with better decisions. Types of decisions: we have strategic, we have tactic, and operational. Strategic are long-term decisions and they are made on high-level departmental tables. Tactical, they're made on moderate managerial tables. Operational, they can be made on daily and day-to-day operations. Advantages and challenges of decision analysis. Our first advantage, we can say, it can give us better or more informed decisions. It's going to improve our objectives and also help us in allocating resources. We're going to have efficient strategic planning. The challenges that we undergo while carrying out decision analysis: we have time consuming in terms of gathering data and model building. Gathering data from all your staff, from consumers, from managers, it's very time consuming. It can be costly because we use statistical tools to carry out decision analysis. Tools like RStudio, such tools are usually paid for. Then the probability estimates may be inaccurate. Probability is a win or lose. Sometimes you may overcalculate or underestimate, and you end up making a decision on such data. In short, your results will not be accurate. You won't get what you expect. Thank you. I would love to pass on to the next speaker.
Thank you very much, Rachel. Mayanja Ali, you can add on to decision analysis.
Thank you very much, Melissa. I'm going to continue where my colleague has stopped on decision analysis, and I'm going to talk about the decision environments. These include three: certainty, risks, and uncertainty. Certainty is probably known outcomes, risk is probabilistic outcomes, and uncertainty is unknown or unquantifiable outcomes. So under certainty, we use deterministic optimization. At risks, we use expected value and probability modeling, applied statistics. And uncertainty, we use qualitative rules, which are the maxim and the maximus. So let me go to the steps of decision analysis. There are 4 steps of decision analysis, namely framing the decision, identifying the alternatives, assessing the consequences, and evaluation. Framing the decision is probably defining the problem clearly. Number 2, identifying alternatives. This is listing all the possible options. Number 3 is assessing consequences. Here, we assess the model outcomes. Number 4 is evaluation. We apply the expected value and decision tree, and we use it to determine the decision which we are going to partake. I'm going to give you a case study of the Nile Breweries capital investment decision, where Nile Breweries had to decide on how to expand capacity to meet the rising East African export demand. 3 options were given, which were 1, to automate the plant, B, which was lease extra factory, and C, which was do nothing. We use the probabilistic model and we come up with the high demand, which was 4.2 million profit under the first option of automating the plant. We come up with the expected value, where we multiply the probability times the actual profit which was given, and we sum the high demand plus the moderate demand and the low demand, and we come back with the expected value. We under automating the plant, the expected value came up to be $2.5 million. Option B, which was lease an extra factory, where we rent an extra factory and help in production. The expected value came up to be $1.99 million. And under option D, which was do nothing, the expected value was $0.5 million in profit, which was very low. So we came up with the best decision, which was A, to automate the plant, where the expected value hit 2.55 million, and it came up to be the best decision for Nile Breweries. Thank you.
Thank you very much, Mayanja Ali. Moving on to, we have scheduling, and I would like Sentongo Stephen to take us through.
Thank you, Melissa. Now, scheduling is a process that makes the company to be organized in such a way that it is the process of organizing, controlling, and optimizing manufacturing workloads, materials, and resources to meet the customer's demand on time. And under this process, it ensures minimizing both production time and costs. Once this process is met, there we shall see decreased costs, fewer shortages, customer satisfaction, and better reputation of the company to the public. Now this brings us to the scheduling methods, and these are 5. And the first one is the forwarding scheduling. Once the first task is finalized, the company goes on to the second task there and then. There is no waiting. That is the forward scheduling. We have the backward scheduling. Here the company estimates the customer's due date and then calculates backward. In this scenario, there is a scenario where the company has got an order that is within 7 days, and the lead time, it is 4 days. So in this case, the company has to start the production not later than the 3rd day. So that's the backward scheduling. So that in this case, once the 3 days, on the 3rd day, the production starts. By the end of the 4th day, the lead time, the order will be will be submitted. Then you have the parallel scheduling. In this case, there are multiple tasks operating in the company at the same time on different machines. So different tasks are operating, but on various machines. So there is no redundancy. Then you have the sequential scheduling. And under this scheduling, it's like a step-by-step scheduling. In this case, imagine a scenario where a company, it's a bakery, and it goes into various steps. That's mixing the ingredients, the baking in the oven, the cooling, the icing and decoration, then the packaging. In this case, the company has to use various methods. For example, you can use the shortest processing time, or the Johnson's rule, to choose which order comes in first. Imagine a scenario where the company has three orders. It can use either the Johnson's rule to show like which task goes in first. So in that case, it is ensuring that these last steps, that the cooling and the decoration, they don't remain redundant. And this brings us to the dynamic scheduling. In this case, it's like dynamic means means changes. In this case, the company has to optimize to changes in their scheduling. Imagine a scenario where it's mainly used in hospitals. Let me say a doctor has a routine of 3 patients per day. And these patients they have minor flu, but unfortunately there comes in an ambulance that has brought in a patient with cardiac arrest. So in this case, the doctor has to use something like priority based scheduling to ensure that this patient who has come in first and has the cardiac arrest can be worked out, can be worked on first, then the others will follow. Thank you, Melissa.
Thank you very much, Stephen. I would like to invite Joel to give us an addition of scheduling.
Thank you, Melissa. I'm going to talk about the principles and job models of scheduling. I'll go straight to sequencing principles. Sequencing, basically, here, this basically means what goes out first. The first principle is first in, first out. Processes orders in arrival order. The second principle is thank you, Melissa. I'll talk about the principles and shop models of scheduling. I'll go straight to sequencing principles. Under this, the first principle is first in, first out. Processes orders in arrival order. Fair and simple. The second principle is shortest processing time. Here, we basically look at prioritizing quick tasks first to boost throughput. And the third is earliest due date. This tackles the nearest deadlines first. The fourth is critical path method. This identifies the longest dependent task chain to determine minimum project duration. I'll go to shop scheduling models. The first one is flow shop. Every task follows the exact same machine sequence. The second is job shop. Each order takes its own unique machine routine. And the third is open shop. Tasks can be completed in any way. In any way the manager wants them to be done. Here, we are given a case study of Kachila Sugar, malt job sequencing. In this scenario, Kachila Sugar has 4 customer orders waiting on a single refining machine. Management must decide the processing sequence to minimize average completion time. Here we are given order B, D, A, and C. We are given the processing time, due date, SPT sequence, and days late. In this scenario, we can see that order B takes 2 days to be done, and the exact days where it's supposed to be done is 5. So in this scenario, we are supposed to find the average completion, whereby we are going to add 5 plus 7 plus 9 plus 11 and divide by 4. So there we shall be getting the average completion, which is 16.27 days, where the all orders of B, D, A, C will be done. Here we are given the second scenario of Bidco Uganda, new production line. So in this scenario, we are given A, which is Projua equipment. We are given B, civil works and planning. We are given C, electrical installation. We are given D, equipment installation. E, safety and compliance audit. We are given F, which is staff training. We can see that Projua equipment takes 5 days, civil takes 8, electrical takes 4, equipment installation takes 6, safety 3, and then staff training 3. And in this scenario, all I can say is that in Projua equipment, electrical installation can never be done before we procure equipment. And again, we can see that equipment installation should be done when the electrical installation is done. Same to staff training should be done after the equipment installation is done. So we can see that procure equipment takes 5 days, and then electrical installation takes 4 days. So here we shall have a day of installing the machinery before the procure equipment is done. So talk about the civil works and plumbing and the safety and compliance audit. These don't affect the A, C, D, and F. Here we are supposed to find the critical path, which is A plus C plus D plus F plus G, whereby we shall divide by 6, and we shall be getting 20 days to accomplish the given task. Thank you so much.
Thank you very much, Joel, together with Stephen, for taking us through scheduling. Moving on, we have forecasting, and once again, my name is Melissa Huangen Abigail, and I will be taking you through the first part of forecasting. So forecasting in production would be using of past data and statistical models to predict future demand, costs, or events. And with forecasting, management of a production farm is able to make decisions, they're able to plan, budget, and review different performances of how the farms are producing. Then we have the time horizons, where we have the short term. This is planned for up to 12 months. And we have the medium term, planned for between 1 to 3 years, whereas we have the long term that's planned for between 3 to 10 years. And for short term, we have the operations and flow managers that usually come up with the scheduling and inventory replenishment, basically operational needs of a production farm. And here they use tools such as moving averages and exponential smoothing. For example, we have MTN Uganda, where it sits down to forecast weekly SIM and SIM card activation and demand to plan for dealer stock distribution. Then we have medium term that is basically forecasted by departmental managers. And here they use tools such as regression analysis and seasonal decomposition to come up with a tactical decisions such as supplier contracts, budget cycles, and any adjustments that would be required in the production farm. For example, we have, when it comes to Mukwano Industries, it can forecast the annual cooking oil demand to negotiate palm oil import contracts, such that the supplier knows for how long they can grow and when to supply the Mukwano Industries with oil. We have the long term, which is planned for between 3 to 10 years. And this is handled mainly by the board or senior management, such as the directors, shareholders, and they're able to use tools such as the Delphi method, scenario planning, and the trend analysis. When it comes to the long term, they're able to look at the investment decisions, plant expansion, are we going to open up other outlets in other countries, areas, etc. This brings us to the models of forecasting, where we have the qualitative models, and this deals with mainly questionnaires, and it also comes in when the farm has little or no historical data that exists. So a farm will carry out market research through consumer surveys, engage with the consumers about a product or a product that is going to be launched, that is a new product. Then we have the quantitative models, where this deals with raw data and numerical data, in other words. And under this, moving averages are mainly used, where they consider recent periods. For example, a farm will consider the previous 2 months or 3 months to come up with the average of sales and prices in general. I would like to invite my colleague, Mirembe Phyllis, to take us through forecasting.
Thank you, Melissa. So to continue, here we are dealing with measuring accuracy. So we all know that forecasting deals with prediction. So in that, when you're predicting, obviously it's not going to be accurate. It's going to have some mistakes in it. So here we are measuring the accuracies. So we are going to have these different models that are going to help us measure the level of accuracy and the level of mistakes that you can incur when you're using that given forecast. So to start with, I have MAD, that is mean absolute deviation. Here, when you hear mean, obviously you know that you're going to deal with like averages. So the formula is you get the actual minus the forecast out of the number of months that you're going to use. So here, when you have like 2 days and then you have like 1, you consider the 2 equal to the 1 because all of them give like an equal mistake when you're using this model. So here you collect them, you get the average of like the forecasting models, the data that you have. When you divide it, it will give you like the average of the mistake that you're going to incur. So here it is simple and it is widely used because when you deal with things in terms of averages, it gives you an easier perspective of like a big amount instead of like going each and every one of them singly. So to follow the next one, MSE, mean squared error. So this one deals with like the big mistakes. So if a firm sees a small mistake, it won't focus on it because it will be like that will give you a small penalty. But what if you square root it, like you square it, you times it twice? What will it give you? It will give you a double penalty. So here it's dealing with large errors that are going to be incurred when you're using that forecast. In that, if a company is to incur like 5 mistakes when using that forecast, how will it be if it's to incur 5 times 5, which is 25? It will give you obviously a larger penalty than when you're using one singular mistake. So here it is widely used because it will give you like a perspective of like that larger mistakes that would be incurred when you're using this forecast, and it will help businesses know the amount of costs they will incur if they use this given forecasting approach. To go with the next one, mean absolute percentage error. This one we are going to deal in terms of percentages. So when a company hears like you're dealing with five mistakes, it won't give it as a big response as when it hears a 5% mistake, because they'll be like 5% on like a 10% average. They'll be like 5% is half of the 10, so we shall give it an immediate response. Or if it's like a 1%, they'll be like that one is not an immediate solution, or it's not like giving big mistakes. So they will use this percentages when they want to compare things, and it will give them clear view of like the mistakes they will get when using that forecast. So to continue, I have here a scenario, a case study of Umeme Uganda electricity demand forecasting. So this whole scenario, we are looking at a forecast of January, and we are going to use the past months of December, November, October, September, and August. And here we are using 3 monthly moving average, and also the exponential smoothing. So to give light on the 3 monthly moving average, here you see it's giving 3 monthly. So meaning you're going to get the average of the past 3 months, and that average will give you the next forecast of January. Why? Because when each average, when you're using this formula or this model, you treat the past months the same way you're going to treat the exact near one. So all of them are going to give you an equal. So here you're getting the averages, which will give you the average of January. Using the exponential smoothing, this one we are going to use the exact month, the one before. So meaning we're going to use December. And this gives you a constant figure, that is the 0.65. So you'll use this constant figure and you'll multiply it with the actual value of December plus the 1 minus the figure, the constant, times the forecast of December. And this will give you a forecast of January. And when you compare using the 3 monthly moving average and using the exponential smoothing, you see that using exponential is going to give a larger and broad figure of January. So meaning this one, it's giving you an exact or like an almost perfect forecast. So here companies will use this because it's giving you a larger and broader forecasting figure.
Thank you very much, Phyllis. And that's what we had as Group 2 evening regarding decision analysis, scheduling, and forecasting. Thank you very much. See you next time.